synchronous messaging, and you might be going, what's this guy talking about? So yes, I think it's a good time to talk about this now. I was going to leave it till a bit later when we came on to talking about message buses, but I think since we're starting to do some messaging now, I think it's a good place to actually put these slides in. So yeah, let's talk about synchronous and asynchronous messaging. So what is synchronous messaging? In short, it's basically talking about a request response cycle type setup. Okay, so as a client, I'm going to make a request to a HTTP endpoint in this case, and I'm going to sit there and I'm going to wait until it responds back. Okay, so the requester will wait for a response. This is probably going into maybe a bit too much detail at this stage, but generally speaking, and it's probably quite a controversial statement, and I'm probably going to get lots of hate mail for this one, but generally speaking, services such as our command service and our platform services, when they're servicing requests to external clients such as a web application or Insomnia, those type of external facing services are synchronous. Okay, that's a very common pattern. When you're talking about service to service communication, i.e. within our cluster, for example, and it's just services talking to each other, you can use synchronous communication for sure, and we're going to do that. But for the most part, we, in this video anyway, are going to be using asynchronous communication, and I'll come on to what that is in a bit. That might be a bit of a controversial statement, but yes, for the most part, externally facing services are definitely synchronous. They don't tend to be asynchronous. That's less controversial, all right? Synchronous services usually need to know about each other. So as a requester, I need to go and know exactly, explicitly, I need to request that service for some reason, and I need to know where it is. Now, I put usually in brackets because there are things like service discovery and service meshes and all that kind of stuff where you can maybe have that kind of automatic service type discovery. We're not covering that here today. So for the most part, what I'm saying is if you're making a synchronous request to an endpoint, you need to know where that endpoint is. You may go, well, why is that? Why is there an issue with that? Well, it becomes a bit of a management overhead. If your service is calling another 10 other services, it needs to know exactly where all those 10 other services are in order to call them. And it becomes a bit cumbersome. We're going to be using two forms of synchronous messaging today, HTTP, which we'll come on to doing next, and gRPC. All right. Now, this bit I really wanted to put in because it can get a bit confusing. So I've just said HTTP is a synchronous messaging construct. Cool, and it is, right? So I'm not retracting that. A very good question, it's a question I had initially as well, was hang on, wait a minute, if I've written a controller, which we have done, and I've got some action results in there, I can mark those action results as async. Doesn't that make it an asynchronous messaging construct then? The answer to that is no, and I'll tell you why. So from a messaging perspective, as you can see on screen, say we did tag one of our action results as asynchronous, from a messaging perspective, the method is still synchronous. Any client making a request to that endpoint still has to wait for a response, okay? The async stuff is really all to do with the way that in service manages its threads internally. From a client perspective, from a messaging perspective, anybody requesting that service still has to wait for a response, so it's still synchronous messaging. Just to clarify, async in this context, the C# language context, means that the action will not wait for a long-running operation. So say that action result is doing some lengthy database dip, or maybe even calling another service. If it's long-running, what that async keyword means is it's not going to wait, it's not going to maintain hold of its thread while that long-running operation executes. It's going to return the thread back to the thread pool. Okay, so yes, it says here it will hand its thread back to the thread pool where it can be reused. When the long-running operation finishes, it will reacquire a thread and complete, and then respond back to the requester. So all this time, the requester in this scenario has still been sat there waiting for this service to respond back. This whole async construct is purely about thread management internally for that service. Messaging perspective, it's still synchronous though. So yes, as it says there, async in this context is really about thread exhaustion. The requester still has to wait. The call is still synchronous. Okay, so async in this context is about C# language, thread management, nothing to do with messaging. HTTP is still a synchronous, by and large, messaging construct. All right. So synchronous messaging between services can and does occur, and we're going to implement this. So as I said, this is all coming back to this. Do services talk synchronously to each other? We are going to do this. However, it does tend to pair services. It does tend to couple them a little bit, creating a dependency. Now again, in the microservices world, one of the kind of tenets is that you want to try and decouple where possible. You don't want lots of chatty communication between services. They're going to have to talk to each other, and there's a bit of a paradox here, but for the most part, you don't want lots of inter-service communication, and you certainly don't want it in a synchronous fashion, I don't think. And it could lead to something called, additionally, it could lead to something called dependency chain. So let's look at this diagram here. Service A makes a synchronous call to service B. Service B then has to make calls to services C and D, and service D then has to make a synchronous call to service E. So you can imagine if there's delays between any of those request response cycles, or if one even fails, what's going to happen. Not a fantastic result. And service A is probably going to be sitting there waiting for a long time. You also have this horrible kind of, the name says all dependency chain, where each service needs to know exactly what other service to call. It starts to get a bit cumbersome. You might have heard the term spaghetti programming, maybe not fully applicable in this state, but you get the idea. It becomes a bit of a mess, okay? But nonetheless, we are going to implement it to begin with, and there are scenarios where it's probably the better pattern to use as opposed to using an asynchronous event-based pattern. And we're going to implement that with gRPC a bit later. So I'm not saying you don't use synchronous communication, I'm just saying you've got to, as a developer, you've got to make that decision about which is the best to use from a service-to-service perspective. All right, so asynchronous messaging. There is no request-response cycle. The requester does not wait. Sounds good, doesn't it? It's more of an event model, and for example, a publish-subscribe type model. Typically used between services, again, might be a controversial statement. There's some people out there that would probably disagree with that, but this is my video and this is what I'm saying, so go with it. Event bus is often used, and again, we're going to be using RabbitMQ much later down the path. We'll introduce RabbitMQ. And services don't really need to know about each other. They just need to know about the bus. So the idea is, as a requester, I just need to talk to the message bus and put something onto the message bus and go, here you go, here's something that other services need to know about, or here's some information that I potentially need. And I just put that onto the message bus, and the message bus sends out these events to any other services that are subscribed to those events on the message bus. Those other services will receive an event, go, oh, okay, I've got this new event, and then will respond back onto the event bus in that kind of fashion. So it's event driven. The event bus kind of sits as an intermediary between services, and it's a publish, subscribe type model, event driven model. And we're going to go into that quite a bit in this video. It does though introduce its own range of complexities, and it is actually much more complex than a synchronous request response cycle. It does introduce a lot of other things, that make it more complex. It's not a magic bullet by any means. So then the final slide in this section, and it's a question I wanted to surface here, is, isn't the message bus a monolith? It's this big thing that all these other services are dependent on. To some extent, yes. And it's the same kind of conversation you'll have about API gateways. Is an API gateway basically a monolith? Again, to some extent, yes. But focusing in on the message bus, is it a monolith? Yes, to some extent, yes. Internal comms, if services are reliant on the message bus, internal comms between services would stop working if the message bus went down. However, if you've designed your microservices appropriately, those services should be autonomous enough that they can still deal with external traffic, they can still deal with requests to them and be able to deal with them to some extent, even if they cannot talk to other services internally. So yeah, services will typically still be able to operate and work externally, with some caveats, of course. The message bus, therefore, because it is so important, should be treated as a first-class citizen, similar to the network, physical storage, power, any of that stuff. And so typically, when you're setting up a message bus in a production environment, you'd set it up in a clustered fashion. You would have fault tolerance, you'd have multiple instances all talking to each other, so if one goes down, it's not an issue. And again, that's how RabbitMQ themselves recommend you set up RabbitMQ in Kubernetes using this cluster type approach. We're not going to do that here. It's a bit too complex for this video. It's just an introduction video. So we're just going to set up a single instance of RabbitMQ for our purposes. But generally speaking, in a production environment, you would have this cluster. The other thing I put there is you'd also typically have, a degree of persistence. So if your cluster dies and then it restarts again, it's not lost all the messages that it had in the queue. It should have some degree of the ability to retrieve messages it had in its queue from some persistence layer. That being said, services should also implement some kind of retry policy. So say the message bus goes down, you don't want to just fire messages onto it, and then if the message bus is gone, you've lost that event. The services should be intelligent enough to retry, keep those events queued up and retry when the message bus comes back up. So something you'll hear about often in the microservices world is you aim for smart services. Your endpoint should be intelligent, the pipes should be relatively simple or stupid, as I've put there. Okay, so they're really just there as a transport to get one event from one service to the other. All right. So with that, again, I just wanted to introduce you to this concept of synchronous messaging. We're going to be talking about it a lot, and asynchronous messaging, we're going to be talking about it a lot. When we come on to asynchronous messaging and RabbitMQ, we'll do a full section on that a bit later. But for now, we're going to move back over to our platform service and implement a synchronous client that will allow us to talk to our command service. So we'll do that next. All right, so back over in our command service, we're not actually going to work in our command service now. We've got everything we need in here for the moment. So I'm just going to close down the running service. Now, I'm going to leave our command service running in this instance of VS Code, and I'm going to bring up a separate instance, a new window, for our platform service, because we're going to be working in there now. So in our new instance of VS Code, I'm going to move into my working directory, season 4, and change into episode 3. And I'll do a quick directory listing to make sure I can see a platform service. And then I'm just going to open that in this instance. Cool. All right. So we have our platform service up and running now. So yeah, what we're going to do is create a HTTP client effectively. It's going to issue a post message to our command service. Now this is just a test really, we're not really going to implement too much functionality here, but the idea would be that if we created a new platform in the platform service, that we would want to let our command service know about it, because our command service is somewhat reliant on platform information. And one way we could do that is by sending a HTTP post payload over to our command service, and it could then take that and do with it what it wants. We're going to properly implement that using a message bus type construct. So using an event publisher subscribe type model, we're going to properly implement it doing that. Here, we're not going to fully implement it. All I really want to do here is just make sure that we've got comms working between the two endpoints, more especially when we come to putting it into Kubernetes. This is more actually a Kubernetes thing, really just setting up the networking between our services. And I'm doing this just to test that, help test that. Nonetheless, it's still a valid use case, and we want to make sure that it's all working. So back in our platform service, we're going to create a new folder for our synchronous data services. So new folder, and I'm going to call it sync data services. And we're eventually going to end up with two types of synchronous data service, HTTP that we're doing now and gRPC. But we're going to just focus on HTTP for the moment. So new folder, HTTP. I'll make sure I capitalize H. All right. Now, we're going to make use of something called a HTTP client to make the request. And moreover, we're going to make use of something called a HTTP client factory to basically give us a HTTP client. And then I've done videos on this before. The main reason we're using HTTP client factory is if you're making multiple requests using HTTP clients, you should be using a factory to do that for you, because it just manages connection safety and all that sort of stuff, and you don't end up with, again, connection exhaustion and all that sort of stuff. So we're going to be using a HTTP client factory, but if you follow along with the code, it should be relatively straightforward. So the first thing we're going to create is an interface, because we are going to use constructor dependency injection, and we're going to inject this client into various places, namely our controller. So we want to allow constructor dependency injection from that perspective. So new file, and we're going to call it I command data client.cs. And then we're going to define namespace, platform service, sync data service, services.http. Fantastic. And it's just a public interface called I command data client. And we're just going to have one method signature. It's going to be asynchronous, and you'll see why in a moment. So we'll have to bring in the namespace for task in a second. And we're just going to call this send platform to command. Now, we're not really going to do anything with this, but I thought just to kind of make it a bit more of a realistic example, if we come over to our DTOs, the idea is we want to send over a platform that we have created. And we have two DTOs here. We have our platform read DTO with all this information in it, and we have a platform create DTO with this information in it. Now, I'm thinking in this case, when we send a platform over to our command service, we probably actually want to include the ID, our ID, because we probably want to give it a reference, a unique reference to the platform that we've created, so it has that. So I'm going to use the platform read DTO as the message that we pass over, okay? So in here, I'm going to say platform read DTO, and we'll just call that plat. So we're going to bring in a few namespaces here, so control period to bring in platform service DTOs, and we need to bring in threading for this. Okay, great. So that's our interface created. So I'm just going to come on now and create the concrete class. So again, within the HTTP folder, new file, and I'm just going to call this HTTP command data client.cs. Okay, specify the namespace, platform service, sync data services, and as we've typed this in before, you can see it's remembered it, which is cool. And then it's just a public class called HTTP. And I realize I've just spelled that wrong, so let me just rename that. Command data client, yep, so HTTP command data client, and we're going to implement the I command data client. So we'll do a control period, implement interface. Fantastic. Now, before we actually come on and implement this method here, what I want to do is make use of this HTTP client factory. So in order to do that, we use, once again, constructor dependency injection here. So we're going to create a constructor for our class, and into it, we're going to inject the HTTP client. And you'll see how this all ties together when we register this service in our startup class. And we're just going to call that HTTP client. So into here, we're going to get this HTTP client injected, but we do need to bring in the namespace of using system.net HTTP. Fantastic. And again, we need to create a private instance. So I'm going to call underscore HTTP client is equal to HTTP client. And in here, control period to generate a read-only field that we can use throughout the rest of our service, or service method. Put it in here, use it in here. Okay, so let's just save that for the moment. And now we're going to come down and actually implement our send platform to command synchronous call. So the first thing I want to do is create a payload effectively that would contain our platform read DTO or information. So I'm going to do a var, call it HTTP content, and it'll be a new string content object. Open parenthesis, I'll just put in the semicolon. And the first thing I'm going to do is I'm going to serialize this object, this platform read DTO. So I'm going to use JSON serializer. I spelled that correct. No, I've not spelled it correct. Serializer. I think that's right. Yeah, so using system text JSON. Now you can see you get two choices here. You could use the older Newtonsoft JSON library. I'm using the Microsoft library moving forward now, okay? And we're just going to serialize the platform object so we can send it over the wire, basically. All right. And in the encoding, bring in the namespace for that, should be system text, there we go, is going to be UTF-8. And then finally, we just need to specify the media type, which is going to be application JSON. Okay, I'm going to bring that back up onto this line here. Okay, so this string content object is something we're going to send over with our post request. Okay, and it's still complaining because we're not really returning anything as yet. And then we're going to basically make a post async request to our client. So I'm going to do var response equals await. Use our HTTP client, post async, and I'm just going to do a control B to get rid of our sidebar. You can see what's happening. And here we don't have a problem at all because we will solve it, of course, but we need to know where, and again, this is talking about kind of your pairing services to one another. We need to know where to send this post request to. Now we can just hard code the URI of our service in here. Okay, but that's not a particularly elegant solution. So what I want to do is I want to move in and put this type of stuff into config, okay? But for the moment, let's just hard code it, and we will eventually come back and put it into config so that it's not hard coded, which is never a great idea. So basically what we want to do, let's come back over to Insomnia. And when we tested our inbound connection in our local environment, this is the URI or URL that we want to send this to. So we'll just copy this in for the moment. Again, I just want to get this up and running and working, but we'll circle back and put this into config. Okay, so paste that in there, and then we need to supply the HTTP content along with this as well. And it's complaining, the await operator, okay, so we need to put in async up here. There we go, and that should resolve that. So basically it was complaining that we couldn't call an await method when this method signature wasn't asynchronous itself. Okay, so we're going to post to our endpoint and we're going to provide that HTTP content. Cool, and then all we want to do then is just check that we get a successful or otherwise response back. So if response is success code, then we'll do a console write line. Bring in the namespace using system, write line, and we'll just say sync post to command service was okay. Otherwise, console write line. And I might just copy this message here. And we'll say it was not okay. All right, fantastic. So let's save that off. Okay, so we've still got a couple of things to do. We want to bring in configuration rather than hard-coded strings. So what we can do actually is up here in our constructor, where we're injecting in a HTTP client, we can also inject iConfiguration. Big duration, and we'll just call that configuration. Okay, we'll bring in the namespace for that. Now, iConfiguration is one of those lovely objects that gets injected everywhere, basically, or can be injected everywhere, so you don't really have to do too much setup there. The other thing to be really careful of, and I've made this mistake, is that bring in the right namespace for iConfiguration, because Automapper also has that too. So make sure it's the Microsoft extensions configuration that you bring up at the top, okay? And then we will set up a private field, so call it _configuration and make it equal to configuration. And then control period, generate a read-only field. There we go. And we can use this configuration now to inject this in from a config file. So I'm going to copy this and I'm going to do a control B, and we're going to come over to our configuration file. So we have our app settings development JSON configuration file, which seems like a good place in which to put our config for our endpoint from a development perspective. So what I'm going to do is I'm going to come over to here and into our app settings.development JSON. I'm going to create a new parameter in here, and I'm just going to call it command service. And the value, I'm actually just going to make it the kind of base URL for our command service so we know where to get to it. So we'll save that off in here and we'll come back to our command service. I'll do a Control B to bring this down. And what I'm going to do is I'm going to take this out and I'm going to make use of string interpolation to inject in that part of our URI into our endpoint here. Now you could put the whole thing, to be honest with you. You could actually put the whole thing in. I'm just putting the server URI, but you could put the whole path in if you wanted, which is entirely up to you. And I'm just going to make use of configuration. So basically, what we get injected in here, configuration, and then just reference the setting that we put in here, which was command service. So just copy that and put that in here. And make sure you get the forward slash. So basically, this thing here, all the way up to here, is basically going to be HTTP localhost port 6000 and then the rest of the URI. Now again, you could replace the whole thing if you wanted in here with that. Entirely up to you. In fact, do you know what? Let's do that because it doesn't really make sense, does it, to just have that little bit. So let's just put that in here like that. That makes more sense, doesn't it? Yeah. Okay, so basically we're just going to put the whole thing in. All right, so that should work now. Actually, no it won't. There's one thing that we still need to do, and I'll just take this out. I don't know how that got in there, so let's save that off. Now, because we're using this HTTP client factory ultimately, or we're getting a HTTP client injected in, we need to make use of a HTTP client factory in order to do that. So this is the last bit of this section. It has been a bit longer than I had intended, so I do apologize, but Control B, and back over in our startup class, what we want to do in our configure services method is under our repository registration, we're going to make use of our services collection again, and this is where the HTTP client factory gets used. So we're going to add HTTP client, okay? And we're going to specify the interface. So in this case, it's going to be I command data client. So when we ask for an I command data client, we're going to give it a HTTP command data client. So this is us basically, this add HTTP client is making use of a client factory. And so when, let me just bring in the namespaces for these, and both should resolve them as they're in the same namespace. That's correct. So they have resolved. So back over here, when, I'll do a Control B, when our class constructor gets called, we're going to get a HTTP client injected in here that's going to be managed by a HTTP client factory. All right, so that was quite a long section. We need to test this now, so we'll do that in the next video, just to might have a cup of tea now, and then come back and we'll test this and make sure, test it locally, make sure that when we make use of this, and we'll have to put this into our controller in a second, we'll do that in the next video, when we call this service, we can actually send a message down to our command service, but we'll do that in the next video. All right, so still in our platform service, what we want to do is we've created our synchronous client, our HTTP synchronous client here. What we want to do is we actually want to be able to use it somewhere. And so where are we going to use it? Where does it make sense to use it? Well, it probably makes sense to use it from our platform's controller. So when somebody runs a HTTP post and we create a platform in our platform service, at that point we want to make a synchronous call, or do we, to our command service to make them aware, hey, we've just created a new command. All right, so we're going to put that code in here and then we're going to test it. So just do a Control B just to give us a bit more breathing space. So the first thing we need to do is actually inject in an instance of our command data client into our platform's controller so we can use it. So I'm just going to take a new line for our injected parameters because it's going to get a bit long. So we'll still keep platform repo, we'll still keep IMapper, but now what we want to inject in is an I command data client, and we'll just bring in the namespace for that. So using platform services, sync data services HTTP, that's cool. And we'll just call that underscore command data client. And as usual, we need to create a private instance of it. So I'm going to call it underscore command data client equals command data client. There we go. And, oh, hang on. I should just create that. Yeah, there we go. That's right. There we go. That's better. So yeah, make sure the one that you're injecting has not got the underscore and the one that we are creating now has got the underscore. Okay, so generate a read-only field. And again, this pattern should be very, very familiar to you now. And again, coming back over to our startup class, because we've registered this here, we have this available to us in here as well. Okay, so we just come down to our post endpoint. And just before we return back with our created it route statement, I'm going to make a call to platform service at this point. Now, because things could potentially or conceivably go wrong, I'm going to use a try catch block because we don't want some horrific exception if that endpoint is down, for example. So I'm going to make use of the await keyword. I'm going to make use of our command data client. I'm going to send platform to command, and I'm going to pass in platform read DTO that we've got here. Okay, and that should be sufficient for this. And it's going to complain here, but we'll fix it up basically because this is not an asynchronous endpoint. And again, I will stress async in this context has nothing to do with asynchronous messaging. But before we do that, we'll just catch any exceptions. We'll call it EX, and then we'll just do a console write line with something of the nature of and we'll use string interpolation, so we'll put $sign before the double quotes, and we'll say could not send synchronously. And there may be reasons for that. I don't think I've spelled that correctly. Have asynchronously. That's right. Doesn't really matter, but for those of you who hate spelling mistakes, it probably is quite annoying if it is wrong. And then we're going to just pass in the message that we get from any exception. Okay, so hopefully this makes sense. So we'll try and send, use our data client to send our platform read DTO to our platform service. If it fails, we'll catch an exception. Now again, this is complaining because it's saying there is no await operator, but that's okay. So we can just put that in here, make it synchronous. But in order to do that, we have to specify it's a task really that's being returned. So task, and then close that off like that, and that should be okay. Not await, async. Okay, there you go. So async, await. And I don't think we have the threading namespace, so we'll bring in using system threading tasks. So this has now made this action result an asynchronous action result because potentially this command here could be long running. But again, to labour the point, from a calling perspective, it's still asynchronous messaging. So let's save that off. Let's bring up our command line. Let's do a .NET build. Looking good. We'll do a .NET run. And again, just to be, super sort of pedantic, you can see here that, I should say it here, it usually says it. There we go. The hosting environment is development, okay? So because the hosting environment is development, it will make use of our app settings.development JSON file and pull in the right config for our command service endpoint. And actually, what we might do, I'm just going to stop running, and what I might do is up here, in our startup class, what I might do is in configure services, I might just do a bit of an output just to say console write line, and we'll just say, just so we can see this printed to the screen, command service endpoint. And we will make use of our configuration object called configuration in this case. And we'll just specify this So we'll have this printed out to screen, and because we'll probably do this quite a lot because we're going to be moving between different environments, so it's probably worth just printing out to our console what it thinks the endpoint is. So let's just start that again. There we go. So you saw there what it thought the command service endpoint is. There we go. So this is what it thinks the endpoint is, and indeed that is exactly what we should be using. Seeded data, all good. So that's our platform service up and running. Let's move back to our command service. Let's make sure that's running. Fantastic. And then what we're going to do is we're going to make a platform create request in our platform service, which should then call our command service. All right, so moment of truth. So bring up Insomnia once again. We're in our local development environment and we want to create a platform in our platform service. Okay, so let me just send this over. Looks like it created it. And we'll come over to our messaging, and you can see here within our command service we have an inbound post from our command service. Fantastic. And we come back over to our platform service, we have a message saying the synchronous post to our command service was okay. So that's all working rather nicely. But what I'm going to do, just to illustrate a point, I'm going to come back to our command service and I'm going to stop it. I'm going to kill it. Okay, so that endpoint is no longer there. And I'm going to do the same thing again and we're going to see what happens. Okay, so we'll create the same thing again. So let's just click send. You can see it's taking time. Still comes back okay because it created the service okay, but you saw that took 2 or 3 seconds. Why did it take 2 or 3 seconds? Well, basically, if we come back to our platform service, you can see we could not send synchronously, no connection was made, blah, 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 which totally makes sense. But you saw how, as a consumer, we were waiting for that, okay? We're waiting for that response to come back. And you imagine there's a chain of those type of things or anything like that. Not a great experience. Nonetheless, we have achieved what we wanted to achieve. And just to recap, it's been quite a long section. We have created a test endpoint in our command service, and we've created a synchronous data client in our platform service that will call this test service in our command service synchronously. Cool, so we've established that that works. What we need to do now is put our platform service into Kubernetes and then wire up these 2 services using cluster IP addresses. So we're going to do that next. All right, so let's just do a quick sense check again of where we're at and what we've done. So we have our platform service running in Kubernetes and we have our node port set up. We do not yet have our command service running in Kubernetes, but we have it running locally and we had established connectivity between the 2. That's cool. So in this section, what we want to do is, first of all, get our command service up and running in Kubernetes, and then we're going to create cluster IPs for each of our pods so they can talk to each other. So really the first thing we need to do, the first step of getting our command service into Kubernetes is packaging it as a Docker image and pushing it up to Docker Hub. So we're going to do that now. So let's just make sure we're in the right space. We want to be in our commands service. So we're here, so we're in commands service, and you can see here we're in the right space. So do a quick clear the screen, and what we want to do is create a Docker file. So in the root of our commands service project, we're going to right click, new file, and I'm going to create a Docker file as we did before with our platform service. Now, all I'm going to do is come back over to our platform service and copy out the config from our platform service Docker file, because it's basically effectively exactly the same, bar one small change. All right, and that's down here, that's the entry point. So rather than it being platform service DLL, it's going to be command service DLL. Now let's just double check in the bin folder. We want to make sure that the DLL commands service is matched here. It's exactly the same thing. I actually made a mistake in one of the other recordings of this video and I got this name wrong and it caused all sorts of issues. So just make sure that you have the right entry point. And we'll save that off. Okay, and then as before, we'll do a Docker build. And we'll tag it with your Docker Hub ID. and then the name of the service, command service. And don't forget the build context at the end. Alright, so we'll go away and build that. Should be relatively quick. Fantastic, and then we'll push it up to Docker Hub. So get rid of the build context, get rid of the T, and we'll just type in push, and this will push this up to Docker Hub so that when we create our K8's deployment for our command service, it has an image to go away and pull down. So we'll just let Docker do its thing and push that image up, and then we'll come back and we'll actually test and make sure that our Docker image is actually running as well. I probably should have done that before I pushed it, but we'll wait, we'll let the push finish, and then we'll test and make sure that it actually runs up okay. Now interestingly you can see here that it's saying layer already exists, so because it is aware of layers for this image elsewhere, it doesn't have to push the whole thing back up. Okay, so that's pushed up. Now before we do anything else, I should have done this before I pushed it, we're going to do a Docker run. So Docker run, we'll specify an external port mapping to an internal port mapping, which you should be familiar with now. I'm not going to run it in detached mode because I actually want to see the output when we run it. So just the name of the service. Okay, so binary thistle command service. Let's run that up. It's cool. So it's run up okay. It's started on port 80. We're not getting any errors, so that all looks pretty good to me. So what we might do is come over into here, and we can see that we have a command service running. So I'm just going to stop that from here. And we get our command prompt back. So that all looks good. So in the next section, what we're going to do is we're going to update our platform's deployment file to include a cluster IP service, and we're going to create an entirely new commands deployment file that also includes a cluster IP service. So we'll do that in the next section. All right, so let's come over to our K8's project. And here we have our existing platform's deployment. Now that's not actually going to change, that's staying exactly the same. But what I do want to do is come underneath here and add in a definition for our cluster IP service. Now you could put this into a separate file if you want. I like to keep it in this instance in the same file, as the two things are really very closely related. All right, so we specify an API version, and this time it's v1. So this will look very similar to the node port stuff that we did a bit earlier. The kind is a service, and then metadata is basically the name of our service effectively. So we'll specify name, and we're going to call this platforms cluster IP service. These names get quite long, so you've got to really check your typing. And I guarantee you will make a typo at some point throughout this course. So just be really, really meticulous with your spacing and with the naming of your services. And they have to be absolutely exact. If you're one character out, as has happened to me many times, nothing will work. So you really got to double check. And if you do run into trouble, just download the config file from GitHub and you should be okay. Anyway, so we've specified the name of our cluster IP service, and I'm just going to specify what type it is, and it's of type cluster IP. Capitalize that, and then selector, tab in, app, and we come up here and we actually pick the name of our template, which is platform service in this case. I'll just make sure I've not copied too much space there. There we go. I'll paste that in here. Again, you've got to get this stuff absolutely correct. We'll back out and then we'll define our ports. And then it's an array. So we'll give it a name. And again, I'm going to give it the same name, platform service as well. Tab in, protocol is going to be TCP. Port's going to be 80, and target port is also going to be 80. And that's it for now. We will add another port onto this for when we come on to doing gRPC, but for the moment we're just using plain old HTTP, so this should suffice. So our actual deployment hasn't changed yet, and we're adding a new cluster service IP into that. So let's just save that off for the moment. We're not going to apply that yet. And then we're going to create a new deployment for our commands service. So right click in here, new file, and we'll call this commands depl.yaml. Okay, and what I'm doing, I'm going to come in here and I'm going to copy all of this, and I'm just going to do a bit of a replace for our command service. Okay, so let's just work our way down from the top down to the bottom and replace the things that we need to replace. So the first thing we're going to change is the name of our deployment. So rather than it being platforms depl, it's going to be commands. The name of our service is going to be command service. And maybe we just come back over to Docker Hub and we just take a quick look at, just double check the name of our service. So it's command service, not plural. Okay, so command service. And I'm going to copy this because I'm going to replace it everywhere. I'm going to push it in here. I'm going to push it in here. And I'm going to push it in here as well. Okay, so binary thistle command service latest. Let's come down to the cluster IP for this service. And again, we're just going to change this instead of platforms to commands. Cluster IP is okay. And I'm just going to change the selectors to what we already had. There we go. That all looks good. So if I just highlight this, we should have these same things highlighted throughout the rest of the file. And we'll save that off. Okay, that all looks good. Okay, so just to reiterate what we have done, we have built our command service as a Docker image and we have pushed that up to Docker Hub because we need that for our deployment. And we've now updated our platform's deployment to include a cluster IP service, which has not yet been deployed. And we've created an entirely new commands deployment that contains the deployment for our service and also cluster IP. So in the next section, we're going to run both of these deployment files to get everything up and running. But just before we do that, there is one little bit of config we need to pop back into our platform service just before we do that. So we'll do that next. All right, so I was talking about we need to make a bit of a change to our platforms service config. So back over in platform service, we need to know where our command service resides. And this is one of the problems of synchronous data services. If you're doing it this way, you need to know where all the endpoints are. And so we've created a config entry in our app settings development JSON file that tells us where we can find the command service in a development environment. And that's all cool. But when we deploy into Kubernetes, it's an entirely different environment. It actually runs in production. So this bit of config, number one, is not going to get picked up. And even if it did get picked up, it's going to be incorrect anyway because the command service is not going to be running here. It's going to be running somewhere else. All right, so the first thing we need to do is create another settings file just for production, just for our production settings. So I might just clear down a lot of this stuff because it's getting a bit busy. And come back over into the root of our project. I'll just minimize some of this to give us a bit more room. And we're going to create a new app settings file in the root of our project. So new file, app settings.production.json. Okay, and so these are the settings that are only going to get picked up in a production type environment. All right, so we come back over here. I'm just going to copy this. Copy, and I'm going to come over here and create some curly brackets and create this as a top level item. So that's point number one, that's all cool. But where is our command service going to reside in Kubernetes? Well, if we come back over to our K8s folder and we look inside our commands deployment, we have created this cluster IP service for our command service. So again, come back to our architecture diagram because I think it's worth revisiting. Let's come back here. What we are attempting to do is get our two services to talk to each other via their cluster IP services. So really the endpoint from a platform service perspective, the endpoint it needs to reach out to is really the cluster IP service attached to the command service pod. Okay, so the name basically that we need to put in is this here, the name of our service. That is effectively the endpoint our platform service needs to reach out to. So I'm just going to copy that and come back to our platform service. And in our app settings production JSON, I'm just going to replace this here with the cluster IP service of our commands service. And I also need to specify the port. So the name of the cluster IP service, port, and everything else should remain exactly the same. All right, so again, you know, a little bit kind of convoluted, but you know, there's a lot of config involved in setting all this up. And again, you're probably going to make mistakes along the way. Don't stress if you do. I've made plenty. But the other thing to note here is because I've effectively changed our image now, created some new settings and app settings JSON, I'm going to have to repackage, rebuild our Docker image for our platform service and re-push it back up to Docker Hub. So let's do that now. Let's build it. And let's push it up. So I'm just doing up key, so Docker push binary thistle platform service. And it shouldn't take that long as we've only made a minor change. Now, going forward, you would probably want to extract the settings out of settings file in this way and not have to redeploy images to read in this type of stuff. But again, for this video, I've chosen to do it this way, just in the interest of time. But you can see this probably isn't a particularly efficient way of changing your settings, having to redeploy an image, but that's what we're doing here anyway. So once that's pushed up, what I'm going to then do is we're going to then apply our deployment files, the two files that we've run, and we'll run into another interesting concept when we come to doing that. So there we go, that's pushed up. So I'm going to pause here for a minute and then I'm going to come back and we're going to revisit the two files that we've created, because as yet we've not reapplied them, and then we'll do our final test to make sure that we get our services talking inside Kubernetes. So we'll do that next. All right, so let's just do a quick sense check of where we're at. So let's come back into our K8s project. And I'm going to bring up our command line. I'm just going to clear that down. So the first thing, I want to just, you know, level set on where we're at, because we've done quite a lot of work and it can get confusing. So let's do a kubectl get deployments. Okay, we only have one deployment up and running, which is our platform's deployment. It's been deployed, it's all cool, looks good. If you do kubectl get pods, you can see we have one pod up and running, which is our platform service. So again, we've created these files, but we've not yet applied them. And then the last thing we'll do is we'll do kubectl get services. And you can see here we have this Kubernetes cluster IP, which is already there by default, and we have our node port that we created a few sections ago. All right. So the first thing I want to do is I want to apply our platform's deployment again. So quick directory listing, make sure we can see our platform's deployment file. And we're going to do kubectl apply f and the name of our deployment file. So let's do that now. And let's run that. Okay, now you can see a couple of things here. It's saying that the deployment has remained unchanged. Okay, and that's fair enough, because this part of the file, what's really referring to is the deployment here, the deployment we've actually specified in this file, and that hasn't changed. That's remained exactly the same. But what it has said is we've created this new cluster IP service, which all sounds great. So if we do kubectl get services, you should see we have this platform's cluster IP created, which looks good. But coming back over to our Kubernetes session, and pulling this over here, we have our pod running and we have our platform service running. What hasn't happened by rerunning that deployment file, Kubernetes hasn't gone up to Docker Hub and pulled down the latest version of our image that has our new configuration pointing to our command service. It's not done that. If we just come back over here and go into it, you can see that, it's not restarted, it's not done anything, whatever. So what we need to do is we need to force Kubernetes to refresh this image. Okay, so the way we do that is we come back over here and we'll just do a kubectl get deployments just to get a list of our deployments again. I spelled that wrong. Yep, there we go. So we've got our platforms deployment. We want to basically restart that or refresh that. So the way we do that, again, this is all in the cheat sheet, these command lines, kubectl rollout, restart, deployment, and then we just specify the name of the deployment. Okay. And then it says deployment apps platforms depl is restarted. And if we come back over to Kubernetes, we should see some things happening over here. Whoop. Or alternatively, rather than doing that, we can just do kubectl get pods. And you can see that we have a container that's running already, but we have this container that's now creating, which is the new container with our new image, with our new config, and it's creating. And eventually this running one, it will terminate once that one has started. So we just have one running now, which is good. And if we come over to Kubernetes and we have a quick look here, you can see one pod has died, and then we come over to our platform service. You can see here, the command service endpoint is here. So it's picked up the right endpoint, certainly, that we've told it to pick up. This is what it will be looking for when we hit the controller. It will then reach out to our platform service. But that won't work at the moment because we don't actually have our commands service deployed. So we'll do that now. And it's relatively straightforward. So back over in K8, let's just clear this out. We'll just do, again, kubectl get deployments. We only have one deployment, so we now want to execute our commands deployment. So again, we'll just do an up key. We want to apply our commands deployment this time. Okay, so kubectl apply -f commands deployment. And you can see this time, we didn't have a commands deployment at all, so it's gone off and created one, and it will pull down the image it has for that. And then it's created a cluster IP service for that as well. Fantastic. So if we do kubectl get services, you'll see we have our two cluster IP services, one for commands and one for platforms, which is good. And then if we do kubectl get deployments, up and running, both are up and running, and we'll do a kubectl get pods to see the health of our pods. And we have two pods up and running, a commands pod and a platforms pod. So that's all looking quite promising. Fantastic. So we'll just come over again to our Kubernetes instance. Let's make this bigger. And you can see we have a pod for platforms, a pod for commands, a platform service, and a command service. And we click on the service, it all looks like it's running okay. So that's looking pretty exciting. So final step here that we want to do is just test that that is working. So we're going to make a call into our platform service, a post request, and we're going to see if we are talking to our command service. So we'll do that next. Fingers crossed it's all wired up correctly and it's all working correctly. So we'll do that. Yeah, we'll do it next. All right, so let's get testing this. So to test, we're going to use Insomnia. So we're going to be testing purely within our K8's environment. And so all we have so far is the ability to get platforms from our platform service. So let's just run that and make sure that's still running okay. That's good, that's a good start. So what we want to do next is then create a platform in our service running in Kubernetes. So let's come down to our local dev, and I'm just going to copy or duplicate the create platform call, and I'm going to move that into here. Now at the moment we are using a node port, and again we're reliant on this port here in order for that to happen. So let's copy that, and we'll come down to here and we're going to paste that in here. Okay, so hopefully you remember that from when we were looking at node ports. We were just calling a create platform, but we're having to use this node port endpoint. And we'll just, again, we've only got 3 platforms in our platform service, so we're going to create hopefully another one. Now what we expect to see is that number 1, a platform will be created in our platform service. fantastic. But more importantly, what we want to see in the logs of our command service is that it received that post notification. And if it receives that post notification, then we know that everything is wired up correctly, and we're really quite far down. We've broken the back actually of a lot of the Kubernetes networking stuff, which I appreciate is quite quite voluminous and quite boring. So fingers crossed, let's click send.